everybody, and hope you're all doing well. Today we're going to continue my how-to series about how to rig and go on from the torso section to the legs. We'll go over more about what is IK and what is FK and make a highly versatile rig for one leg. Please note that we're just doing one leg today, but making the other leg is just a matter of repeating the process for the other side. Alright, let's get started. Alright guys, so here in Maya we got our last project that we were working on, the torso, and I've added on the legs to this. So what I'm going to do is hide the torso for now and just work solely on the legs. So I'm going to go ahead and turn on X-ray. So first off, I just wanted to explain what is IK and what is FK. So let's just go into our rigging menu and just make a joint chain. So basically for FK, we have something where the parent controls the child. So let's say this joint is parent to these two children. If I rotate it, the children are going to rotate with the parent. And if this parent is parent to this child, and then I rotate it, it rotates the child. And what an IK is exactly the opposite. So if I go to skeleton, create IK handle, and I create an IK handle, it's going to be the child controlling where the parent goes. So there's two different kinds of IK handle that you can make. If I just go to this little option box, I can create a single chain solver, which is just standard IK handle that we have a child controlling the parent joints. And then we can also create, if I go into my create IK handle, something called a rotate plane solver. And what that does, if I create one, is it makes this little thing on top called a pole vector. So if I create a null object or a locator, I bring this out here. So if I select the locator and then I select the IK handle and I go to constrain and click on pole vector, I see that now I have a directional from this locator for where the center of my IK handle will go. So that is good for aligning a knee. So if you want the knee to twist or to specify a location for the knee to turn, you can use this as the way to do it. So I'm going to delete these. And then we're going to look at our foot. So I'm just going to go to my side perspective and start creating a chain for this foot. I'm going to go to skeleton, create joints, and start with the hip, move to the knee, to the ankle, and to the ball of our foot, and then to the toes of our foot. So the first thing I'm going to do is label these joints. So this one is hip result. The result skeleton is the base skeleton of our mesh. And that's how we're going to name them. And then we're going to select all of these and check the local rotation axis. Go to display, transform, and local rotation axis. So everything looks pretty good according to what I had from beforehand, except for my knee joint. So I'm going to select my knee joint and go into skeleton and click orient joints. And I'm going to orient this so that the primary axis is X, secondary axis is Y, and the secondary axis world rotation is Z, so that Y faces the front. And I'm going to do the same for this one. And click close. And then looking at this, it's in the center, so I'm going to bring it to the side and just work on one leg for now. So I want to start creating my IK handles. So I want one IK handle that is from the hip to the ankle. So I'm going to go into skeleton, create IK handle, and click my hip joint. and then my ankle joint. And this should already be set to the rotate plane solver. So that'll create a pole vector. So I'm going to create a locator and assign that as my pole vector to where my knee is going to point to, and move it about right in front of my knee, right there. And then select it, and then select my IK handle and go to constrain and pole vector. And that should give me a place so that I know where to point my knee when I twist my leg. So next thing I'm going to do is create an IK handle from my ankle to the ball of my foot. So I can control the ankle with the ball of my foot. And then an IK handle from the ball of my foot to the toes. So I can control things in that fashion. So go back to skeleton, go to create IK handle and click on the little checkbox and switch this back to single chain solver. Click on the ankle and then to the toe. Go back to skeleton, create it again, click it from the ball to the toe. See now if I move my IK handle, I can move that whole chain like how I want it. So I can't control all these IK handles by themselves. So I'm going to want to build a rig that can control all these IK handles. So what I'm going to do is go back to my side view and create a joint setup. So this is called the reverse IK foot. So I'm going to create a joint here right at my heel, and then create a joint here at my toe, and then create a joint back here at my ball, and then create one at the ankle. And then I'm going to click insert and snap these joints to where my other skeleton is at. Hold down V and snap them. Okay, so now that I have all of these snapped to their appropriate joints, I'm going to rename them. So this one is going to be named heel control joint, and this one is going to be named toe control joint. This one is going to be named ball control joint, and ankle. So the next thing I'm going to want to do is to parent these IK handles to their appropriate joints. So let's say I'm at the ankle joint. I want that IK handle to be parented to the ankle control joint. So I'll select the IK handle at the ankle and select the ankle control joint and click P to parent them. Select the control handle at the ball. Select the ball joint and parent it. Then select the IK handle at the toe. Select the toe control joint and parent that. So now you see if I move the heel control, it should move the entire foot. So we're not going to be able to set keyframes on these joints. So how we're going to do that is to create controllers. So I'm going to create a NURBS that's a circle as a controller and make that about the size of the foot and the shape of the foot. And I can kind of refine the controller a little bit more to get it to be a little bit more pleasing. And I could be able to tell right and left. And then I'm going to place this anchor point for this control to the ankle. So I'm going to click Insert and then move this to my ankle. Hold down V to snap it. And that should give me a good center of rotation for this foot. Then press Insert again. So the first thing I'm going to do is rename this foot. So right foot control. And then I'm going to go to Modify and freeze this transformations. And then Edit and delete all by type history. And then I'm going to select the heel control joint, control select the controller, and click P. And that should parent my heel control joint to my controller. And this is how we want to move the foot, is with this control joint. So I can rotate it, to the side, I can move it left and right and turn it. But I still want to give the foot a little bit extra mobility. I still want these things such as the toe control or the ball control to be able to rotate by themselves. So I'm going to do that by adding what is called a driven key to this control. So I'm going to go to Edit and then go to Add Attribute. And I'm going to name this called Roll. And I'm going to keep this as keyable. And then this is data type as float. And then attribute type as scalar. Click Add. See, it's going to give me this little box with a value that I can put in for what is called row. So I'm going to link up this row value to these joints by going to Animation and go to Key and click on this Set Driven Key and Set. So I'm going to load one thing first as my driver, so that's what drives the driven. So I'm going to load the control as my driver. And then you could see my row value shows up here. And then what is driven is going to be my 3 joints. So I'm going to load the heel joint, the toe joint, and the ball joint all as the driven. So load driven. So what I'm going to do is when the roll is set to 0, right now I'm going to set a key for the rotate Z on the heel joint, the toe joint, and the ball joint. Control click them and set a key by clicking key. So this will give me a basic 0 value for the roll. And then I'm going to change the value for this roll to 10 and translate the rotate Z for toe control to maybe 40 and then press key. So now you see if I move this roll input, that's going to control my ball and allow my leg to tilt forward, and the character is going to be able to stand on its tippy toes. And then I'm going to set this controller back to 10. And on my ball control, I want that to rotate as well. So rotate Z on the ball control, select the ball control, and then rotate. And then press key. Now if I go back to my roll attribute and middle mouse and drag, I'll be able to roll my entire foot forward. And the last key that I'm going to make is on the heel control. And I'm going to set this to -10 on the roll. And then for the rotate Z on heel control, I'm going to set the rotate Z to 56 and then press key. So now if I roll backwards, it's going to allow my entire heel to move back. So now I should have full mobility on the foot. And the last thing I'm going to do is to select the IK handle here for the toe and group that to itself. So Control G, and then name this toe up control. And then I'm going to select my controller and go to Edit, Add Attribute, and add an attribute called toe control with the same settings as before. So for this toe control, what I want to do is have these toes the ability to lift up by themselves independently of the entire heel. So I'm going to be able to do that with another driven key here. And I'm going to go back to key, set driven key, load the controller as the driver again, and then load this toe up control as the driven. And select my toe control and my translate Y, which is the up axis here, and click key, add 0, and then change this toe control to 10, and then select my toe control group, move that up, and then click key. So now you see I have this nice attribute that can move my toe up if I wanted to. So finally, we're gonna cut this mesh up so that I could see my deformations a little bit better. So just like last time, I'm gonna split this mesh according to where the joints are. Now remember, this is solely for the proxy mesh. Proxy mesh is going to be deleted later on and replaced with the actual geometry when we bind the skeleton. But for right now, it'll give us a good opportunity to see how things deform. Then I'm going to parent these pieces of the proxy geometry to the result joints, like I did before. That'll give me a good idea of how things will rotate when I actually rotate this character. So I could check my toe control here. Yes, it moves up. And then I could also check my foot roll here. See how that looks. And that's how I would want things. So I hope that was helpful. And we're going to keep going to the arms in the next lesson. And I'll see you next time.